Temperature measurement, halija mai anak belong. Anasia gam anak ansid, Nicodemus libin. What is temperature? Temperature is defined as the measure of heat thermal energy associated with the movement kinetic energy of the molecules of a substance. This definition is based on the theory that molecules of all matter are in continuous motion that is sensed as heat. Temperature is a physical quantity expressing the degree of hotness and coldness. It is measured with a thermometer calibrated in one or more temperature scales. Unit of temperature, most commonly used scales. Celsius scale denoted C. Fahrenheit scale denoted degrees Fahrenheit. Kelvin scale denoted K. Degrees Fahrenheit, used to record surface temperature measurements by meteorologists in the United States. Kelvin is another unit of temperature that is very handy for many scientific calculations, since it begins at absolute zero, meaning it has no negative numbers. This is unit conversion. Absolute zero temperature, the temperature where all motion stops. Theoretically, the coldest a system can be is when its temperature is absolute zero, at which point the thermal motion in matter would be zero. However, an actual physical system or object can never attain a temperature of absolute zero. Absolute zero is denoted as 0 K on the Kelvin scale, minus 273.15 degrees Celsius on the Celsius scale, and minus 459.67 degrees Fahrenheit on the Fahrenheit scale. Temperature terminology, boiling point. The temperature where the vapor pressure of a liquid equals the external pressure surrounding the liquid, flash point. The temperature at which a particular organic compound gives off sufficient vapor to generate an ignitable mixture with air. Bubble point, temperature where the first bubble of vapor is formed when heating a liquid consisting of two or more components. Freezing point, the temperature at which a liquid changes to a solid. Melting point, the temperature at which a solid changes to liquid. Absolute temperature, the temperature is noted in Kelvin K or Rankine R. Temperature gauge, types of temperature measuring method. The contact measuring method, when the temperature-sensitive sensor is directly in contact with the measured medium. The non-contact measuring method involves heat radiation from the energy exchanged between measured medium and the thermometer. Example of contact measuring method: bimetallic thermometer, field thermometer. Resistance temperature detector RTD. Thermocouple TC, mechanical temperature device. Response to temperature by producing mechanical action or movement. Usually read directly, disadvantages, slower to react to temperature changes. Electrical temperature device, response to temperature by producing or changing an electrical signal. Advantages, accurate and response quickly to temperature changes. Types of temperature gauge. Temperature gauges are available in different types, each designed for specific temperature ranges, environments, and measurement requirements. Liquid-filled thermometers, bimetallic thermometers. Gas-filled thermometers, thermocouple gauges. Resistance temperature detectors RTDIS. Liquid-filled system. Non-metallic liquid fills the thermal system and works on the principle of liquid expansion. Application: static and non-vibrated machine or process line. Temperature range, -40 to 105 Celsius. Fluid expansion sensors, such as mercury and alcohol-based liquid, do not require electric power, do not pose explosion hazards, and are stable even after repeated cycling. On the other hand, they do not generate data that is easily recorded or transmitted. Gas-filled system, application, wide range of applications. The built-in board and tube system generates a rotational pointer movement that is proportional to the temperature. Governed by perfect gas law, temperature equals constant X pressure X volume. Temperature range, -200 to 700 Celsius. An electronic angle encoder non-contact, and therefore completely free from wear and friction, determines the position of the instrument pointer. From this, the electrical output signal, proportional to the temperature, is produced. Filled system advantages: rugged, do not require electric power. The display can be located at a considerable distance from the measurement. Time response and accuracy are satisfactory for most. Disadvantages: entire system usually must be replaced in case of failure. Large bulb is necessary for accuracy, cannot compete with the performance of electrical device. This is comparison of filled system. Ambient temperature compensation: thermal expansion will have a small impact on the reading. Asterisk: if the range is narrow or the bulb is small and the capillary long, then full compensation is required. Asterisk: compensation is done either using a bimetallic compensator or by duplicating the spiral and capillary. Asterisk: a good practice is to have a large bulb diameter. This is type of compensating systems of filled thermometer. Bimetallic system. Bimetallic devices take advantage of the difference in rate of thermal expansion between different metals. Strips of two metals are bonded together. Asterisk: when heated, one side will expand more than the other, and the resulting bending is translated into a temperature reading by mechanical linkage to a pointer. When the temperature is increased, the amplitude of the vibrations increases, and the average distance between atoms increases. This leads to an expansion of the whole body as the temperature is increased. Bimetallic system: linear expansion. The change in length that arises from a change in temperature T is designated by L. The change in length L is proportional to the change in temperature T, the original length L. Thus, L equals KLT, where is called the coefficient of linear expansion. Thank you.